boring. All right, kind of plain. Let me just make sure we go here. 24. Okay, trapezoid, kind of plain. Really, it only has one property. Where is my trapezoid here? It's here somewhere. There it is. So I have my trapezoid up here, A, B, C, D. Only thing I know about a trapezoid. One pair of opposite sides parallel. We're done with the discussion. So here you go. BC parallel to AD. There's no other properties of a trapezoid. That's it. One pair of opposite sides are parallel. That's it. So I'm not really going to spend too much time on that. The one we are going to spend time is the souped up version, the isosceles trapezoid. All right, isosceles trapezoid. So let me go back, A, B, C, D. Still have one pair of opposite sides parallel. That's still true, B, C, and AD. What's isosceles mean to you from our triangle days? Two sides equal. Exactly for isosceles trapezoid. The non-parallel sides are congruent in an isosceles trapezoid. The non-parallel sides are congruent. And let's start calling them by their actual name. It's called a leg. Those are legs. All right, those are legs. So there's your first property of an isosceles trapezoid too. Legs are congruent. Legs are congruent. Okay, the two other properties. So let's just get through it. I won't even ask. You remember in a isosceles triangle, what was across from the congruent sides? Oh. Same thing in a trapezoid. Except we have a name for these. And those aren't the only pair. Up top, the two angles are congruent. We call these base angles. Base angles are congruent. Do not think base equals bottom, because as you guys can see, the top two are also equal. Base angles congruent. And finally, last one deals with the diagonals of an isosceles trapezoid. Diagonals are, anybody want to guess? You really got a 50-50 shot. Congruent, yep. Diagonals are congruent in an isosceles trapezoid. Remember, this is all isosceles trapezoid. They do not apply to a basic trapezoid. It's got to be isosceles. Questions on the three properties here? Diagonals congruent, base angles congruent, and the legs are congruent. A lot of congruent. All right, let's practice one as a class, and I'm going to let you and your group work. One, I just tried to trick you. The algebra is not tough at all. Does the x minus 1 play into this at all? No, it has nothing to do. Even though I just threw it in there because it freaks people out. They think I got to throw every number in an equation. No, the legs are the only thing that are equal, so set them equal. 3x minus 3 equals x plus 5. That's it. X minus 1 has nothing to do with it. So what do I have? 2x equals 8. X is 4. So we're good there? All right, just let me talk about 2, and then I'll let you and your group try to figure out a way. I got to find x and y. Property I just went over was what? The base angles are equal? But would it make sense to set y equal to 6x plus 20? That's not going to get us too far, right? Not going to get us too far. So I want to try to avoid that. Even though it's true, try to avoid it. So I see two angles that have x in it. Those two. Maybe they have a relationship where I could find x and then plug it back in to get y. That's what you and your group are going to decide. Go ahead, finish up that problem. Talk to each other. Finish up that problem. Set something up to solve for x and then use it to find. Sounds like we're on the right track. So let me start with what is the relationship between those two angles and what equation did you set up to find x here? Let's roll here. 21, what do you got for me?
I think they're supplementary.
They are. Hold on. We knew they weren't congruent, so my question is, did you just guess and you were correct that they're like anybody know why they're supplementary? Go ahead, Scott. You're on your number.
Same side interior angle.
These are parallel lines. So these make them same side, which we know are supplementary. Good. So I got 6x plus 20 plus 4x equals 180. And what was your value of x, Scott? 16. There we go. All good? All right, now take the 16 and use it to find y. How? 12. How can I find y now that I have x?
We put x into the 6x plus 20 equation and set it equal to y.
Because those are both what?
Congruent.
Base angles, and they're congruent. So 6 times 16, and what'd you guys end up getting for y?
116.
116 for y. Good job, everyone. Good work. Plug it back in. Base angles are equal, so y and whatever 6x plus 20 are equal. Any questions there? All right, let me give you a little jump start on the next one. This is an isosceles trapezoid. Finding x. Ooh. Can I fill out any other side lengths right now? What's the other leg? What's the other leg length? 13, right? They're congruent, so that's 13. Oh, wait, wow. What type of triangle do I have over there? Ooh, a right, yeah. And I know, ooh, almost, right? We almost could use Pythagorean theorem. Because I have x and 13. That would be great if I knew what that side was right there, and then I could use Pythagorean theorem. Good luck in your groups. Go. Good luck. How can I find that side? The whole, yes, the whole base is 34. The whole top base is 24. Here we go. Here we go. Almost Pythag. Oh boy. Some tough ones here.
Oh.
Yeah, I guess so. I got 13. So that'd be 13.
So that would just be.
But then again, you can kind of like come on.
Do you just subtract? So this would be 10. Wait, no,
I
mean,
that's
that's 34. That's what I'm saying. That's why we're doing Python to find it. So it would be 10 squared.
Well, why is 10? 13 squared.
So 13 squared is the hypotenuse. 10 squared. So it would be 10 squared would be 13.
Could you do 13 squared plus 10 squared? 17
For this, you guys are. Oh, okay. I bet.
260. 60.
Yeah, well now. We all know it's very difficult. Don't even get this far.
All right, a little less chatter about this, which is fine. Just so we're all aware, in case you ever need it, every trapezoid can be broken up into a rectangle and two congruent triangles. Okay? Can be broken up into a rectangle and two congruent triangles. Why do I say that? Well, if I can break this up into a rectangle in the middle, one side's 24. What's the opposite side? Also 24 right here. I knew the whole base was 34, so that gives me 10 left for this piece and this piece right here. Right? So I have 10 left over for those two, which are equal. Divide by 2. How long was this piece here? 5, yep. So that was 5. Now the second piece is making sure you plug in the correct numbers into Pythag. Because where should the 13 be going? It's across from the right angle. The hypotenuse across from the right angle always goes in for c squared. So 13 squared. And then A and B is either 5 or X. It's up to you. So X squared plus 5 squared. And now we're off to the races. Actually. X squared plus 25 equals 169. Move the 25 over. I think you get 144. So X ended up being 12. Questions? So I needed it just to break it up into a rectangle and 2 triangles. And then the final one, because I know you don't want to go a class without doing a proof. All I'm going to say is this. It's an isosceles trapezoid. And did you see how they give us this right here, this part? AD congruent to BC. Those are the what then of the trapezoid? Legs, which means what about DC and AB? If those are the legs and they're congruent, what about the other pair? They have to be? Okay, that's given. You don't have to write that down. They gave us the legs are equal so that we assume that, hey, no problem. The opposite side, other opposite sides are the parallel ones. And I'm not saying a word. All you guys, go ahead. How are you going to prove those angles congruent? It's an isosceles trapezoid. Go ahead, get after it. I'll give you as much time as we need. So that is how we ended up finishing up this proof.